Morgan Olson in Sturgis, Michigan. We manufacture trucks for the last mile delivery, and we did a project with MachineMetrics, supervisory control and data acquisition. So basically, what we did in our process was we used the DMAIC process: define, measure, analyze, improve, and control. This is mainly a data-driven exercise in terms of continuous improvement exercise. The Kaizen team included our fabrication supervisor, Brian Reed, myself, Dennis, our maintenance manager, Keith Langer, and Mark Hamlin, who is our maintenance tech. We had support from IT, and MachineMetrics sent us a technician. His name was Chris Schaefer to support our integration project. In defining the problem, we had a big issue where we had lack of data-driven machine supervision and live machine monitoring. So we were running our fabrication process in the blind. We had difficulty in justifying machine capacity requirements because of lack of annualized data. Unavailable quick prompting, just in case a machine went down or an operator was not at the machine. Automated downtime categorization. We had paper-based categorization of downtime. And one thing that we did, we tried to step on the scale and see how much our utilization was. And we were shocked to see that it was at 29%. You don't know what you don't know. So we did a 60-day trial, a COVID trial for 60 days, just to validate that the project will be sustainable. We had to get approval, and MachineMetrics partnered with Morgan Olson to get a 60-day trial before we could purchase the full-blown implementation across all three facilities. The machines that we chose for the trial were in Virginia and Michigan. So we had 2 machines in Michigan and 2 machines in Virginia. That was for the trial phase, which was done in the year 2020. During the trial phase, you can see on June 15th, we started with a utilization of 29%. By August 10th, we had moved it up to 69% by using MachineMetrics, visibility and accountability across the shop floor. Another machine category, we looked at in cycle. Was the machine running or no? On June 15th, we were at 41%. By August 10th, we were at 67%. The data was obvious after the trial phase that we need to do something about how we run the fabrication process. So you can see there, by day, we started at 29%. By the time we were done, over the 3-month period, we had reached a high of 72% in terms of machine utilization. This trial phase was mainly done in Michigan in collaboration with MachineMetrics. We tried it also in RINGGOLD, Virginia. We had 2 machines in RINGGOLD, which we used for in the implementation. And you can see we moved from 20 to 31% and 29 to 49%. At this time, we were starting a new facility, so the data was not very clean. This was not a stable plant, but Michigan had been running for close to 30 years, so the data was very valid at one location. Data analysis. In the analysis stage, we started getting downtime by machine, and it could give us a downtime Pareto. So Pareto basically tells us we have limited time, limited resources. Where do we focus on? Initially, we used to have paper-based downtime categorization. They scan it and keep it in a system where no one ever goes back to look at that data. For this, for the capability that MachineMetrics gives us is anyone, anytime can go back and see what machine was performing well and what were the downtime reasons and act on the main reasons for downtime. So this is a dashboard of machine implementation. So we implemented 25 machines in Sturgis, Michigan, and this was in the trial phase. We wanted a proof of concept in the Michigan location before we moved it to Virginia and also the state of Tennessee. It was a quick ROI. We are fully confident that we've been able to recover the costs that we used in the purchase of the MachineMetrics hardware and software. Another key thing was if I'm a supervisor and I come in on first shift at 6 o'clock, I could go back in time and see what was third shift doing. So that's an example of a brake press 182B. I can see on an hour by hour basis how did third shift perform. Again, I could look at a punch machine. I want to see utilization for the punch machine. So I could go hour by hour for the punch machine. How did third shift perform? I was not there, but MachineMetrics gives you the capability to go back in time and see what the performance was. After full implementation, we put a TV in the fab shop office, a TV in the maintenance office, and another TV on the shop floor. It gives you visibility and enhances a sense of accountability for everyone in the production process. Anyone with a username and a password can go into MachineMetrics, look at what the performance was, and basically make assessments on how to move production towards one facility or the other based on performance. At the shop floor level, we have team members who have a tablet basically showing you if you're winning or losing. No one has to come and supervise you. You're your own supervisor at this point. And the operators seem to like it because no one's coming to their area to tell them what to do. The tablet at the station, it gives you a gauge on how well you're doing throughout the day. So a screenshot in Michigan, we had True Punch 1 and True Punch 2. That's a snapshot of time on 6/19/2020. And then on August 6th, you can see the drastic change on a typical day. We moved from 41% to 83% and 37% to 72%. Your typical view in June was very different from the typical view in the month of August. This was for Virginia. As I had mentioned, at this time, we were still starting up this facility. So the data may not have been very clean, but for Punch Genius number one, you can see the change over the 2-month or 3-month period from 18 to 77%. On the left, this is how we used to track our downtime. It's a piece of paper. You could lose it any time of the day. And on the right, you can see how much improvements we have made by digitizing it and keeping that historical data to make future decisions. The manual tracking on the left, it's very unreliable and you cannot easily get data-driven decision-making with that information. On the shop floor at the machine, the most important person there is your team member. The key role of the tablet, you enter your downtime reasons, which is summed up as the day goes. You get a visual indicator of how, if I'm winning or losing, if I'm the team member there. It communicates with maintenance and fabrication management in case of downtimes. You get a visual management at the cell level. So if I'm a supervisor, I just need to walk around the plant and I can easily know what machine needs help and what machine doesn't need help. And also MachineMetrics customizes the tablets based on the needs of the business. So an hour by hour indication of if I'm in the red, I need some help. If I'm in the orange, I'm getting close to the green. If I'm in the green, I'm hitting my standard for the day. So another inaccurate entries of downtime was another reason we had. On the left, you can see we used a piece of paper and relied on team members to write down what downtime reasons they had. On the right, you can see it's a drop-down menu, give me the reason, and MachineMetrics captures that data automatically. And what was typical on the left, you would see increments of 5, 10, 15, 20. On the left, you see 19 minutes, 50 seconds, very precise to the second of what the machine was doing or not doing in case of downtime. So before, after, and impact to operations, a summary, high-level summary of what was done. Our baseline utilization was 29%. Our utilization improved to 73% over the implementation phase. This was close to $500,000 in savings if you just gained 10% as an assumption. No visibility before. Now we have visibility for maintenance, fabrication, and operation managers. And also the shop floor team member has the ability to know if they're winning or losing as the day goes. And the impact to operations is that transparency across the fabrication is enhanced. Lack of machine utilization data. Number three, capacity requirements based on annualized data is now easy, and it's readily available to know, do I need more machines or do I need to reduce my production rate based on the data we get from MachineMetrics. Number four is manual entry of downtime. We have automated entries of downtime tracking now. It's very accurate, and it doesn't rely on somebody to write it down and waste paper and waste time to do it. Manual notification in case of downtime. We get texts to the supervisors and group leads in case a machine is down. So the response time has been cut down significantly. We don't have to chase somebody down basically saying, my machine is down, please come help me. You get a text message with escalation systems. It moves from 10, 15, 20. By the time it gets to 30 minutes, it's on the fabrication supervisor's desk. The sixth one was lack of data to decide between different brands of machines. Today, we can easily tell what machines performs better than the other based on data from MachineMetrics.